My name is Stephen Diegelmann, and I work in Dr. J.D. Tovar's lab in the Department of Chemistry at Johns Hopkins University. I'm developing new biomaterials that are on the nanoscale, so I'm working in the field of bio-nanotechnology. So by looking at the plaques we found in the tissue of Alzheimer's patients, we observed that the plaques were actually made up of very small fibers, and these fibers are very, very long and very narrow, usually 10,000 times thinner than a human hair. What we envisioned in our lab is to model our materials after these plaques. Our new materials are made from basic biological building blocks and designed to self-assemble and form structures that are on the nanoscale. We designed them in such a way that any one molecule will begin stacking with other similar molecules and begin to form structures that resemble molecular nanowires. One of the applications we envision for our new materials is to try to reestablish communication between severed nerve cells. Nerve cells typically function by passing electrical signals between one another, and then when you sever that connection, so if you have a traumatic injury, if you break your back, sever your spinal cord, that communication is lost. And we've designed our new materials to both be electronically conductive and also biologically compatible.
Again, one of the problems with current trying to integrate semiconductor electronics as they exist now with biological systems is the element of what happens at the interface. With the approach that we're looking at organic-based electronic materials, they're carbon-based, they're organic, they're relatively biocompatible, and with the designs that we're looking at, they allow us to incorporate biological signals directly onto the electronic materials.
So this isn't going to be a permanent implant, but more or less it's going to encourage your body to make the proper connections so you can regain functionality. So I really enjoyed all the research I've done at Hopkins so far, and I really look forward to finishing up my graduate career and seeing what else we can come up with.